You know that little magic trick your iPhone does? The one where a video shrinks down into a corner so you can keep watching while you check your messages or scroll through something else?
Yeah, picture in picture.
Exactly, picture in picture. Chances are you've probably used it today, maybe without even
It
thinking.
becomes so seamless, hasn't it? Just part of the furniture in iOS now.
Yeah.
But today we're going to sort of pull back the curtain a bit.
Okay.
We're looking at what it actually takes to make that seemingly simple feature work. We've got this really fascinating case study here.
Ah, right. The developer who saw that iPhone thing.
That's the one. Saw this concept on, I think it was an Instagram reel, basically a live camera feed in a Pipey window. And they thought, hey, I'll try and build that.
Cool idea.
Yeah. But their notes, they show that what looks, super easy on the surface involves a surprising amount of behind-the-scenes complexity.
Exactly. And I love this bit from their notes. Their initial thought was just to vibe code it.
Uh-huh. Yeah, just wing it.
Right. Like, how hard can it be? So our deep dive today is really going to explore just how far that expectation was from the actual reality.
We're going to unpack the key challenges they faced, get a real sense of the kind of intricate steps involved in bringing picture-in-picture to life on iOS using the camera.
So where did they even start? I saw they didn't jump straight into SwiftUI.
Right. That's the first interesting point. SwiftUI is Apple's newer framework, the modern way. But they hit a wall pretty quickly.
A limitation.
Exactly. At the moment, or at least when they were doing this, SwiftUI doesn't really offer a direct, easy way to just grab the live video feed from the camera.
Which, if your whole app is the live camera feed.
Yeah, kind of fundamental. It's a pretty immediate problem. So they pivoted. They went back to UIKit.
Older framework.
Older, yeah, but still incredibly powerful. And crucially, it does provide the tools you need for direct camera interaction. So that switch to UIKit was like the first big decision point.
Okay, so UIKit it is. But even before Pipey, they just needed to get the camera showing up in the app at all, right?
Absolutely. First things first. And, any app that wants your camera needs your permission. Always.
The privacy pop-up.
Exactly. Which brings us to the info.plist file. You have to add this key, NS camera usage description. Think of it as the app needing to write down why it needs the camera.
I need this because.
Right. We need the camera to show your face in the Pie-P window or whatever. It's a core part of Apple's privacy approach. You, the user, have to know why.
Okay, so you write the reason down, but then the app actually has to ask me, right?
Yeah.
How did they handle that part?
Yeah, and you want that to be smooth. They use Swift's newer concurrency stuff async away.
Ah, the modern way.
Yeah. So first the code checks, like, do I already have permission?
Yeah.
If not, it calls request access. And because it's async, the app doesn't just freeze while it waits for you to tap allow or don't allow.
Keeps the interface responsive. Nice.
Exactly. Much better user experience.
Okay, so permission granted, hopefully. Now, the real mechanics. Getting the camera feed. You mentioned an AV capture session. Sounds important.
It is. Think of AV capture session as like the central command center for the camera.
Oh.
It manages the inputs to the camera itself and the outputs where the video data goes.
Gotcha.
And the developer did something smart. They created a dedicated dispatch queue, like a separate work lane, just for handling the camera stuff.
Why do that?
It keeps all that heavy lifting off the main thread, the one that handles the user interface. So the UI stays smooth, no stutters, while the camera's doing its thing in the background, so to speak.
Okay, so the AV capture session is the conductor. What's next in the orchestra?
Well, you tell the session which camera to use, front or back. Then you set up an AV capture video data output. This thing actually grabs the raw video frames from the camera.
Like frame by frame.
Yep, frame by frame. And it packages them up into these things called CM sample buffer objects, just chunks of video data. And here's a really key link.
Yeah.
They set their main code, the view controller, as the sample buffer delegate for this output.
Delegate, meaning?
It's like the view controller signs up for notifications. It tells the output, hey, whenever you have a new frame, let me know. That delegate method is the function that gets called with each new frame.
So frame arrives, camera taps the view controller on the shoulder. Got it. Now, these raw frames, I saw the developer mention tweaking them. Something about rotation and mirroring.
Ah, yeah. Good catch. That's important. So think about how you hold your phone, usually portrait style. The camera sensor inside might actually be oriented sideways.
Really? Huh.
Yeah. So set at the video rotation angle, they use 270 degrees, corrects for that, and make sure the video isn't sideways when you see it.
Makes sense. And the mirroring is video mirrored to true.
That's usually for the front camera. It flips the image horizontally. So when you look at the feed, it's like looking in a mirror, which feels more natural for like a video call or a selfie view, your right hand appears on the right side of the screen.
Right, okay. Intuitive. So, orientation fixed, mirroring set. How do you actually show this stream of data? You mentioned CM sample buffer thing, sounds raw.
It is pretty raw data. You need something efficient to display it. That's where AV sample buffer display layer comes in. It sounds specialized because it is.
Okay.
So the developer made a custom UI view. Let's call it sample buffer display view. The clever bit is they overrode a property on this view to tell iOS, hey, for this view's main drawing surface, its layer go. Don't use the standard one. Use this special AV sample buffer display layer instead.
Ah, so it's like giving the view its own dedicated high-performance video screen.
Exactly. It's optimized specifically for taking those CM sample buffer objects and getting them onto the screen smoothly. Much better than trying to, say, convert every frame to a UI image or something inefficient like that.
Okay, cool. So custom view, special layer. And back in the view controller, it's acting as the delegate. That AV capture video data output sample buffer delegate thing. What happens there?
Right, so that delegate protocol has a key method, something like capture output.dateOutput.from. This is where each CM sample buffer, each video frame arrives.
Notification inbox.
Pretty much. Inside this method, the developer takes that buffer and basically hands it off to the sample buffer display view's special layer to be displayed. Layer.enqueue, sample buffer.
Gentle as that.
Well, one crucial detail, updating the UI, showing that frame, must happen on the main thread. So they likely dispatch that enqueue call back to the main queue. You don't want to block the camera queue or cause UI glitches.
Right, main thread for UI, always. Okay, so after all that, they've got the camera feed showing inside their app. That's already quite a bit of work.
It really is. Getting the camera running reliably is step one, and it's not trivial. But yeah, now for the main event, picture-in-picture.
How do you even tell iOS, hey, this app might want to do PP?
Good question. It's not automatic. You have to declare your intentions. In the app's project settings, under signing and capabilities, there's a section for background modes.
Okay.
You have to check the box for audio, AirPlay, and picture-in-picture, and probably also voice over IP.
Why both? Or why VoIP?
Well, the PIP one is obvious. The VoIP one, I suspect, is often needed because apps using the camera in the background frequently fall into that kind of category, like video calling. These flags basically tell iOS, look, this app needs to keep doing stuff, maybe playing audio, maybe using the camera, even when it's not the main app on screen.
That makes perfect sense. Otherwise, the system would just suspend it when you swipe away.
Exactly. PIP wouldn't work. And there's another related setting they mentioned, which is super important.
What's that?
On the AV capture session itself, there's a property called Is Multitasking Camera Access Enabled? You set this to true.
Okay.
This explicitly tells iOS 16 and later, yes, this session needs the camera even when the app is backgrounded for PP. For older iOS versions, you needed a special permission, an entitlement, called com.apple.developer.appfoundation.multitasking-camera access.
Yeah, an entitlement even.
Yeah. Point is, without one of these, as soon as your app goes into the background for PP, bang, camera feed stops, black screen.
Crucial step then. So permissions, background modes, multitasking access enabled. How do you actually trigger the PIP window? Like make it happen?
Right. Now you bring in the main player. AV picture-in-picture controller.
Don't chat P-bus.
Exactly. You create an instance of this controller, and the key part of setting it up is giving it a content source.
Content source.
Yeah, it basically tells the controller what to show in the PIP window. In this case, it links that special AV sample buffer display layer, or video screen, with something called a playback delegate.
Playback delegate. But it's a live feed, not a file we're playing.
I know, the naming is a bit confusing. But even for a live feed using sample buffers, the PIP controller needs this delegate to manage things like, well, knowing if it should be playing, what the time range is, stuff like that. We'll get to the specifics of that delegate in a sec.
Okay. And I saw a property mentioned. Can't start picture-in-picture automatically from inline. What's that about?
Yeah. If you set that to true, it allows PIP to potentially start automatically. Like if the user swipes up to go home from your app, iOS might just automatically transition your video layer into the PP window. Makes it feel a bit smoother.
Nice. Okay, now the developer hit a snag here, right? Something about unwanted buttons.
Yes. This is a classic real-world development problem. So the PP window showed up, but it had the standard video controls. Play, pause, fast forward, rewind.
Which makes zero sense for a live camera feed.
Exactly. Totally irrelevant. So the developer thought, okay, how do I hide these? The documentation suggests setting a property requires linear playback to true. The idea is if it's linear, like a live stream, You don't need seeking controls.
Makes sense. Did it work?
Apparently not. For whatever reason, in their setup, setting that property just didn't hide the controls.
Ah, frustrating.
Yeah, this is where you see that gap sometimes between the docs and reality.
Yeah.
So they had to dig deeper.
Find a workaround.
Yep. They found they could use a more, let's say, unofficial method, setValue.4key. It's a way to set properties, sometimes using their internal names.
A bit hacky.
Maybe a little, but it worked. They found that setValue1 for key control style hid the main playback controls. And setValue2 for key control style hid even more, like the close and full screen buttons.
Wow. Okay, so they managed to get the clean PP window they wanted, but not the way they first expected.
Exactly. It's a great example of needing to be resourceful, maybe do some experimenting. When the standard path doesn't work out, developers do this kind of thing all the time.
Resourceful indeed. Okay, let's circle back to that delegate you mentioned, the AV picture and picker sample buffer playback delegate. What did they actually need to do in that delegate for a live feed?
Right. So even though it says playback, it's still essential. There are a few key methods you need to implement.
Right.
Okay, first, there's picture-in-picture controller.setPlaying. This gets called if the system tries to pause or play the PyP content. For a live camera feed, it's always playing, so the developer noted they didn't really need to do anything specific here.
Just let it stream.
Exactly. Then, picture-in-picture controller time range for playback. This asks basically, what's the duration of this content? For normal video, you'd give the start and end time.
But for a live feed, it doesn't end.
Precisely. So you return a special time range, a CM time range, where the duration is set to positive infinity. Tells the system this goes on forever.
Infinite video. Got it. What about pausing?
There's a method, picture-in-picture controller's playback paused. The system asks, hey, is playback currently paused? And for our always-on live camera feed,
The answer is always no.
always false.
Right.
There are a couple of other methods in the protocol, like did transition to render size or skip the interval, but for this specific live camera use case, they probably didn't require much, if any, custom logic.
Okay, that seems manageable. We've covered a lot. Camera setup, permissions, background modes, the PyP controller, hiding controls, the delegate. Are we missing anything major? You mentioned something about audio earlier.
Ah, yes. This is the kicker. The developer really emphasized this point, and it sounds like one of those things that could trip you up for hours.
Oh, what is it?
You absolutely, positively must configure the AV audio session.
The audio system. But it's just video.
I know, it seems unrelated, right?
Yeah.
But you have to get the shared AV audio session instance and set its category to .play and record, and its mode to .video chat.
Play and record in video chat, even if you're not recording audio or doing a chat.
Apparently, yes. For this kind of PyP scenario involving the camera and running in the background, that specific audio session configuration is required under the hood by iOS.
That's weird.
It is weird. And the worst part, the developer noted that if you forget this step or get it wrong, PyP just silently fails to start.
Yeah, no error message. Nothing.
Nothing obvious.
Yeah.
The PyP controller just won't activate when you swipe up. You sit tearing your hair out checking all the PyP code when the problem is actually this seemingly unrelated audio setting.
Wow. Okay, that is a huge gotcha. A hidden dependency. That really highlights how interconnected things are in iOS, sometimes in non-obvious ways.
Totally. It underscores that you sometimes need deep system knowledge, or you stumble upon these things through painful trial and error, like this developer probably did.
So assuming they did remember the audio session magic.
Right, assuming they got all those pieces lined up. The UIKit camera feed, the info.bliss key, the permissions request, the background modes enabled, that is multitasking camera access enabled flag, or the entitlement, the AV picture-in-picture controller set up with the content source and the delegate correctly implemented, the workaround for the controls applied, and the AV audio session configured.
Phew, that's a list.
It is. Then finally, when the user swipes up to navigate away from the app,
It should just work.
it should smoothly transition. The view with the camera feed shrinks down into that familiar floating PyP window and keeps displaying the live camera feed while you go off and use other apps.
That is fascinating. It really transforms how you see that little window. It looks so simple, so elegant, just floating there.
Right.
But underneath, it's this whole chain of dependencies.
Hmm.
Camera APIs, permissions, background execution rules, specific controller setups, delegates, workarounds, and even audio session configurations. Just wow.
And I think the developer's journey here is so typical of software development, isn't it? You start with, oh, this will be easy. I'll just vibe code it.
Yeah.
And then you hit obstacle after unexpected obstacle. You find out the documented way doesn't quite work. You discover these hidden requirements like the audio session thing. You have to find workarounds. It's iterative. It's problem solving.
Absolutely. It's not just writing code, it's navigating the system. And hey, for anyone listening who is a developer or just super curious, the original developer actually shared their final code.
Oh, cool.
They put it up on GitHub. So you can actually go look at how all these pieces fit together in practice. We can maybe link that somewhere. It's a great learning resource.
Definitely. So maybe the next time you're, watching a tutorial video in PyP while looking up ingredients or keeping an eye on a video call,
Yeah.
just take half a second to appreciate the sheer amount of engineering, the complexity tucked away that makes that simple convenience possible.
That's a really great perspective to end on. It definitely makes you think. Now that you, listening, have gotten this glimpse behind the curtain, does it change how you perceive those seemingly effortless features on your phone? What other everyday tech, maybe your smart speaker or your car's interface, might have surprising layers of hidden complexity just waiting to be discovered? Something to ponder.
Definitely food for thought.
Well, thanks for taking this deep dive with us today.
My pleasure.